A few answers from yesterday's quiz. You know what to do, right? You know what to do here. You know you just have to take a picture or a screenshot and take advantage. Don't submit a quiz. And sometimes I can see one student or a couple of students submitting a quiz empty or just one question answered. Take advantage of it. You can have at least 50%. The best thing is to have 100%, right? But you can have at least 50% just by copying this, just by working and checking your answers on this with this information on the screen. Okie dokie. And again, today is a different day. We had a lockdown. We had, I don't know exactly what happened, but we've been in lockdown for over almost 2 hours, and we're gonna have a debriefing later. Probably they will explain to us, to the teachers, what happened. I'm not sure what happened, and I will record this video here to help you out with the homework today. Real quick. We have seen yesterday how to find the greatest common factor, and the first thing you have to find the greatest common factor of the coefficients is a number, right? So that's the way you do. You find the factors of each number and you then identify the common ones and the greatest one among the common factors. If we have, for example, 12 and 16, let me see here, 12, oops, no, it's not working. No, not a problem. 12 and 16, you know 12, the factors are 12, 6, 4, 3, 2, 1. You know that 16, the factors are 16, 8, 4, 2, and 1. And you easily can identify that the greatest common factor is going to be 4, is this the factor that's common to both numbers. And then we have, we worked yesterday on factoring out from a polynomial the greatest common factor. Well, the number is easy, is not easy. You have to do some calculations, you have to find out the factors of the number, but if you have a factor with a variable, then I think it's a bit easier, right, to find the greatest common factor, because it's going to be the lowest power. If you have, for example, 6x exponent 5, 4x exponent 2, the common factor of the coefficients is going to be 2. And if you compare the factors that have the variable x, you will choose the one with the lowest power, the lowest exponent. So it's 2x squared, 2x exponent 2. Let me know if you have any questions about this review from yesterday, because now we are starting. We will work on something new. It's also about factoring, but it's a different kind. It's factoring by grouping. Give me any feedbacks. Let me know if you have any questions about the previous topic, because this is a new thing, a new topic. Well, if you don't have questions, let's move on. When you have a polynomial like this, let me show here on the screen. Let's say you have this, a polynomial that have 4 terms like this. Sometimes you can factor out in a way that you're gonna go and go back to the original binomials that originated this polynomial with 4 terms. Sometimes it is possible, or it's not possible. So on the quiz, we're going to have several examples when we will be able to do this. We will have polynomial with four terms that we can simplify, we can factor out by grouping and find at the end the result as a multiplication of two binomials. This is the objective. Read here the procedure, factoring by grouping. And I know when we read this procedure here, usually we don't understand. But then we apply to the example and it's a bit easier to understand, right? Let's read quickly and then work on the example. Procedure. Identify, the step number one, identify and factor out the greatest common factor from all four terms. And this, yes, you try to find out if you have a common factor of all the four terms. This step number two. Then you're going to split these four terms in two pairs, and you're going to factor out the greatest common factor of the first pair, and separately you're going to factor out the greatest common factor of the second pair. And step three, if the two terms share a common binomial, then you factor out the binomial. Okay, I know if I just read this and I don't know before, I don't understand what this factoring by grouping is, I would never understand just by reading. We need to apply on an example, right? Let's do it right now and apply on this polynomial here. We have 6ab minus 21a plus 4b minus 14. Okay? Check the first step. Identify and factor out greatest common factor from all terms. And I try to identify, but I can say to you, we don't have any common factors of all terms. We don't have. So we can skip this step number one. Step number two, split in two pairs and find the greatest common factor of each pair. That's what you're going to do now. Split in one pair here and another pair over there. And let's find for each one the greatest common factor. First check the coefficients, and the 6 is going to be 3 times 2. Negative 21 is 3 times negative 7, right? So we can write down this as 3, and a is common, 3a times 2b minus 7. This is for the first pair. Now let's work on the second pair. Well, we have the numbers, the coefficients, 2 times 2, and here is 2 times negative 7. We can factor out 2, and nothing else, right? Just 2. Yeah, just 2. It's 2b minus 7. Tell me, can we factor out anything else? Check the results. Check what we found here. And let me know, can we factor out anything at all? And remember the last step. You can read the last step again. If the two terms share a common binomial factor, then you factor out this binomial. Can you find any binomial factor here that is common to both? 3 seconds for you to answer. Let me see if you can identify. 3, 2, 1. No? You cannot see anything? Check this. 2b minus 7, 2b minus 7. It's the same, right? So you can factor it out. You can write down as 3a plus 2 times 2b minus 7. And this is the final answer. This is the result that we're looking for. Tell me if you have any questions. Okay? Again, just to record here, we split in two pairs, and we found the greatest common factor from each pair. Then we factor out the greatest common factor. And after that, we could identify one binomial that's common to both. And we could, in the next step, the last step, factor out this binomial and find, as a result, the multiplication of two binomials. Any questions at all? Can we move on and work on the quiz now? Again, remember, today is a different day because we had some crazy thing, some lockdown, and I don't know yet what exactly happened, but it messed it up with our schedule. If you don't have questions, I need you all to answer the bell work now. Send me a message with the answer for this bell work. How many whole pizzas can you see in the picture? If you check, you put together the whole pizzas, like combining slices, and you can find 5 whole pizzas. And this kind of makes me hungry, because I had a very light lunch. I think I would love to have some slices of pizza right now. Okay, the answer for the bell work is going to be 5. Now let's move on to our quiz. Okay, here it is, and please let me help you with some of the questions. I know the beginning is not too hard. Let me show the first one. Letter A is not too hard, but the last 2 questions, they are a little bit, they have a trick, okay? So the first one, you can factor out y squared, split in 2 pairs, right? And the first one, you can factor out y squared times y plus 4. And the second pair, you can factor out 3. And this is going to be y plus 4. Nice? And check the binomials if they are the same. If you can also factor out the binomial. Yes, nice, they are the same. So you can write down as y squared plus 3 times y plus 4. And this is going to be the right answer. And you can write like this. You can switch position. You can write like y plus 4 times y squared plus 3. Doesn't matter. It's the same answer. It's the right answer. Okay, we have an extra step. I like to start the usual way, by splitting in 2 pairs, and then we can find here on the first pair, we can factor out. Well, this is the numbers, right? We have 6 and 18 is 3 times 6, so we can factor out 6. We can also factor out p, because we have p and p squared and p, and we can also factor out q. Yes. P plus 3. On the second pair, we have negative 30, we can factor out, and also p, because we have p squared and p, the lowest one with the lowest exponent is p. Let me write down a little bit better here, please. 30p times p plus 3, right? This is sweet because we have the same binomial on both terms here. We can factor out the binomial, and we will have 6pq minus 30p times p plus 3. And there's another step on this question here, because if you check this first binomial here, you're going to see that it's possible to factor out a little bit more, because we have 6p, and we can also factor out 6p from here. See, we can factor out the greatest common factor here on this binomial. So you can write down as 6p times q minus 6 times 5, negative 5, negative 30p, times p plus 3. And this is going to be the answer, the final answer here for letter K. Thank you, David. This is letter K. Oops. This was letter K. Anything else? Do you want me to work letter L as well, or G, or the previous ones? K, yes. K is done. Or even the previous ones, A, B, C, D, E, and F. B, yes, sure. Working here on B. Split in 2 pairs, and then you can factor out on the first one B, A plus 1, plus 2 times A plus 1. If we have the same binomial, then we can write down as B. I like to write the A first. A plus 1 times B plus 2. This is the right answer for letter B. And yes, Heaven, F. And Angelina asked it for G. Let me real quick here. Thank you, Davin. Angelina asked it for G. Let me work here quick here on G. Split, and this you can factor out 2x, n plus n, and split here, and you can factor out 3y, n plus n. And this is going to be 2x plus 3 times m plus n. And I haven't asked about f. No problem. Let's go here to f. Split 2 pairs. The first one, let's see what we have in common. We can factor out 2, and we can factor out s. R plus 2, right? And on the second, we can factor out negative 1, r plus 2, right? That means it's equal to s minus 1 times r plus 2. Thank you, Heaven. This is F. Thank you, Angelina. Let me zoom out. We still have less than 1 minute.